differential equation given to us here. It says a slope field is given. Sketch the solution curve through 0, 2. So at 0, 2, I've got slopes of 0, which makes sense because it's going to make slopes of 0, and they lead to more slopes of 0. So looks like that. At 1, 0, I'm just going to kind of follow the trail. Looks like it would go something like that. It says let f of x be a particular solution, given that we have the point 1, 0. So it says write an equation of a tangent line. So in order to write an equation of a tangent line, I need a point, which is 1, 0, and I need a slope. Slope, I'm going to put 1, 0 into here. So if I put a 1 in for x, not much here, this would be negative 2 squared, which would give me a slope of 4/3. So I write my equation, y minus 0 equals 4/3 x minus 1. Okay, and then it says use this equation to approximate 0.7 at 0.7, so I'll do 4/3 times 0.7 minus 1, so I'll do 4/3 times 0.3, sorry, negative 0.3, so I get negative 0.4, 3's cancel, we got the decimal point there. Then the last one says find the particular solution. We haven't seen too many of those. We'll see more in the next couple of weeks, but particular solution means solve this differential equation. So that means separate variables. So I got dy dx, and this is one be a good idea to know how to do because it's always worth a bunch of points. So I'm going to take the y minus 2 squared over here. It's going to be 1 over y minus 2 squared, or y minus 2 to the negative 1. I'm going to take the dx over here. You get a point for that. So 1/3 x dx. So just by knowing you need to separate variables when it says particular solution. So I integrate here. So this would be y minus 2 to the negative 1. Except that would become negative, so it would be negative. So I'll think of this as negative 1 over y minus 2. Excuse me. On the right side, I'll get x squared will give me 2, so I want to turn a 2 into a 1/3, so I'll get 1/3 or 1/6 x squared plus c. At some point, I want to find the c value. You got a point 1, 0. So if I plug in a 1 over here and a 0 over here, I get what 1/2 equals 1/6 plus c. Subtract that, so 3/6 minus 1/6, 2/6, 1/3. So I get negative 1 over y minus 2 equals 1/6 x squared plus 1/3. I would probably combine these. So this is 2/6. So this would be negative 1 for y minus 2 equals x squared plus 2 over 6. You don't have to do that, it just makes the next steps easier. If I'm trying to solve for y, I'm going to flip this over. So I got y minus 2 over negative 1, that's why I did the last step, and then I flip this. Then I put the negative over there, so I got y minus 2 equals negative 6 over x squared plus 2. Add the 2, so I get 2 minus 6 over x squared plus 2. This solution is valid for negative infinity to infinity, it says. Not sure why it says that, but there's my final solution there. Thanks, guys.